Okay guys, today we're going to take notes over the periodic table. Our essential question is, what do elements in the same group have in common? Okay, so let's first talk about what the periodic table is. Okay, the periodic table is where our elements are organized by increasing atomic number. So you need to fill that in on your notes. Now you should know that the atomic number is the same thing as our number of protons, so we're arranged also by our increasing number of protons. And when you did your activity in class, you should have noticed that all the elements, as you look at the periodic table, you should see that they are organized in that increasing number. Okay, in the late 1800s, a scientist named Dmitri Mendeleev came up with the first kind of periodic table as we know it today. Scientists beforehand had been studying these elements, but they didn't really have an organizational system for the elements. They were kind of in a mess. Okay, so Dmitri Mendeleev came along and put all of these elements on cards, kind of like baseball trading cards. And he started playing with those cards and moving them around, and he finally devised a system where he could tell that there were some similarities based on atomic mass. Okay, the heavier elements, but the heavier elements in the system were out of order. So in 1913, two scientists, excuse me, not two scientists, one scientist named Henry Moseley arranged the elements by the atomic number, and that's what we use today. Okay, so if you look at your periodic table, you can see mine looks a little bit different than yours, but we are going by atomic number. Atomic number 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. The periodic table is also arranged in groups and periods. Okay, our groups are vertical columns. Same thing that you would call a column is a group. Okay, we also sometimes call them families, so you might want to write that down as well because those words are interchangeable. Okay, everybody in the same group has very similar physical and chemical properties. Groups are numbered 1 through 18. And everybody in the same group has the same number of valence electrons. Okay, so I know it just says number of electrons, but you want to make sure that you have valence electrons. Okay, all right. So on your periodic table, you might want to make a area where you say our groups run. Oh, excuse me, that's not right. Okay. Let's see, I'm running out of room here. Okay, our groups run vertically, okay, or up and down. Okay, another way you can remember it is in groups. We have a G that goes all the way down, so our groups are going to go long ways like our G. Okay, and like I said, everybody in the same group has the same number of valence electrons. So everybody in group 1, if you were to draw them out, hydrogen, lithium, sodium, potassium, so on, everybody would have the same amount of valence electrons, and that number is the group number. So everybody in group 1 has 1 valence electron. Everybody in group 2 has 2 valence electrons. Okay, now 3 through 12, we have our own special rule for 3 through 12. Okay, they have either 1 or 2. And when we don't mess with these transition metals because they don't follow the exact pattern that we're learning in the 8th grade, so your questions won't ever really be about groups 3 through 12. Okay, now when we get over to groups 13 through 18, we have to do a little special rule for their valence electrons. So we said everybody in the same group has the same number of valence electrons. So when you get to groups 13 through 18, you drop the 1. So everybody in group 13 now has 3 valence electrons. Everybody in group 14 has 4. Everybody in group 15 has 5. Okay, all the way until you get to group 18. Okay, those valence electrons are what makes our elements have similar physical and chemical properties in that group. Okay, it's like a family. Everybody in your family has very similar properties, or they should, depending, I mean, if you're genetically or you're biologically attached to those family members, you should have people who look similar. Okay, now our periods. Our periods run side to side. Those are our rows. Okay, as you go from left to right across the periodic table, okay, our number of protons are going to increase along a period. Okay, and our periods also tell us how many levels, energy levels, we're going to have. So our periods are here. Our periods run side to side. Okay, so our periods are running this way, side to side. Okay, period 2, period 3, all the way across to the other side, period 4. Okay, and that tells us our energy levels. Okay, so you can think of it like, so everybody in group 1, so hydrogen and helium all have 1 energy level. Okay, because they're in period 1. So if you were to draw it out, hydrogen would have 1 energy level and 1 valence electron, okay, because of the group it's in. Everybody in period 2 has 2 energy levels. Everybody in period 3, sodium, magnesium, all the way across to aluminum, silicon, they all have 3 energy levels, okay? So now we're starting to see patterns where we don't have to actually spend the time to draw out our atoms. We can look at the number of valence electrons if it's a neutral atom, and we can look at how many protons it has, and we can go to our periodic table and find them. Okay. Now, here is what we've already talked about. Our first energy level can have 2 electrons. Our second can have 8. Our atom one can have 18. It says 8 on here because remember I told you we get a little weird when we start getting up there. We draw 8, but it can really hold 18 because it's got sub energy levels in it. All right, we've already talked about the electron dot diagrams of the Lewis structure, so don't spend any time writing that down. You don't need to write that down. Okay, the last thing that we are going to talk about are our metals, nonmetals, and metalloids. Okay, now, before you start writing, you already have your periodic table labeled from the class activity. You just need to fill in a couple of these words. Okay, I've left most of it on here so you didn't have to write it. You just need to go back and kind of read over this, read where you labeled your all of your metals. Okay, so all of your metals should be anything. Let me decrease this some. All of your metals should be anything on the left side of the stair step. Okay, so anything that's on the left side, this should all be our metals. Okay, anything that's on the right side of our stair step are our nonmetals, and anything that touches our stair step, except for 2, anything that touches our stair step are our metalloids. Okay, so you need to focus on the characteristics. Our metals are good conductors of heat and electricity. Okay, here are different types of metals. Group 1 is our alkali. Group 2 is our alkaline. And groups 3 through 12 are our transition metals that I've already talked about before. Our nonmetals are usually gases, but some are solids, but they're not very good solids. They're brittle, which means they break easily. Okay, our noble gases are group 18. We've already talked about why group 18 is special. Okay, its whole electron energy levels are full, so it can't bond with anybody. All right, and our metalloids are mixed. They have some properties of metals, some properties of nonmetals. Okay, now the only other thing, okay, that you need to know is that our reactivity, okay, our reactivity, as we go this way, it increases. As we move this way, as we move across this way, we are going to increase our reactivity. That will mean more to us when we get to chemical reactions. But because group 1, here's why. Everybody in group 1 has how many valence electrons? 1. So they have a ton of space open to bond. So they're highly reactive. Think about when you're starving and you're so hungry and you could just eat anything in front of you. That's like group 1, okay? So because they have that 1 valence electrons, they're available to bond and they have lots of energy and they're ready to bond, okay? Group 2 has 2. Skip over, we start filling up. We're getting fuller and fuller. You've been eating your turkey dinner at Thanksgiving and you're getting so stuffed that you can't eat anymore. So you're full, your valence electrons, your energy levels are full and you can't eat anymore. So your reactivity starts to decrease till we don't react anymore over here. Okay? All right, make sure you have your notes and you're ready for class. We'll talk more about this in class. See you then.